So water harvesting is a way to basically take advantage of the humidity in our air and capture that humidity to then have water that we can potentially drink. Often they call these atmospheric water generators, or AWGs. The most common way to do that is based on dewing. So the idea with dewing is that in fact you now condense below the dew point, and then you can change vapor, liquid or water vapor, to liquid. And in that way, then you can in fact have this potentially drinking water. So that's the state of the art, and there have been various people exploring this approach of AWGs, atmospheric water harvesting, where you have to get below the dew point, which means that you have to now refrigerate. So you have to have some type of refrigeration cycle to get to below the dew point. What we've been interested in is a development technology that does not rely on dewing, because it can be relatively energy intensive. And the idea here is to take advantage of novel materials known as adsorbents that can readily capture water from the humidity in the air and soak it up like a sponge, and take advantage of the material properties that allows us to not only soak it up but release it easily at relatively low temperatures to then be able to then condense the water and get the drinking water. And so in particular, while this technology has been well known in terms of adsorption, the key is having the right kind of material to be able to do this. So we've been collaborating with various groups, one of which is with Professor Omar Yaghi at University of California, Berkeley, where they've been developing what they call metal organic frameworks. And these are the particular types of materials that act like this sponge that can readily, easily soak up water, even in relatively low humidity environments. So it could be an arid, desert-like region, and even get the humidity from that type of dry air to then harvest the water. And like I said, what we have done in our lab is in fact now create a device that takes advantage of these metal organic frameworks, or otherwise known as MOFs. And we have been able to demonstrate that with these MOFs, because of the unique characteristics, a device that allows us to now capture water at low relative humidity environments, as low as maybe about 20% relative humidity, and then be able to generate drinking water from that process. I think our type of water harvest device is really meant for remote areas with very limited infrastructure. There are various ways to, in fact, get water that already exist. If you're close to an ocean, then often desalination type approaches are very appropriate, and can be very efficient, and that's commonly used already. What we believe with our specific adsorption-based water harvesting devices is really for remote areas, dry humidity conditions, where there really isn't a lot around that you can take advantage of electricity, for example. In this case, what we're using to heat up and release the water from these materials, in fact, is the sun. And you could do this even without any concentration, no optics, so it becomes a viable platform when you have very limited kind of infrastructure around you. And so I kind of see that it's meant more for, say, it could be delivering water for a family of 4, say. You could create a unit. And so it's more point of use type devices that we're trying to create, rather than, say, supplying water for a whole village all at once. And I see that at that scale, we can in fact create devices that make sense and are viable in terms of also the cost.